Okay, last objective. So now we're really going to get into what simulation is and how to test a claim about a population proportion. We actually are going to spend a lot of time on this in chapters 6, 7, 8. Okay, so there's an activity here I would like you to do about students preferring name brand cookies. So please, pause this video, go to Edulastic, do this activity, and then come back. Okay. All right, so hopefully you've returned back from that activity. It kind of maybe brought to life simulations. So this process of drawing conclusions about a population on the basis of a sample data is called inference. This is a huge idea, right? Huge idea. Drawing conclusions about a population on the basis of sample data. Again, I think we talked about it in the first section of this chapter, that it's somewhat impossible to get every person in the population's opinion, data, all that fun stuff. It takes too much time, too much effort. So sample data is what we use to then make inferences about the population. Okay. Oh, sorry about that. Okay, so I think we're going to take a look at the example here. All right, cool. So it says example 3, is the last chocolate the best chocolate? The researchers gave 22 students 5 different Hershey Kisses: milk chocolate, dark chocolate, creme, caramel, and almond in random order, and asked the students to rate each one. Participants were not told how many kisses they would taste. However, when the 5th and final kiss was presented, participants were informed that it would be their last one. Of the 22 students, 14, or 64%, gave the final kiss the highest rating. This is greater than 20%. The expected percentage of if people don't have a special preference for the last thing they taste. So let's talk about a couple things, right? So first off, right? We're doing this experiment with 5 Hershey Kisses, and we're seeing, does the last one mean something? So when I give you Hershey Kiss 1, 2, 3, 4, 5, do you think that that last one tastes the best because it's the last one you get, it's the last one on your palate? Or is there no real preference? If there was no real preference, then each of them would have a 1 out of 5 chance of being picked as the favorite. And that is where the 20% comes from. So they did this sample out of 22. So their N value is 22. And the number that picked the final kiss was 14. 14 is their sample count. Okay, so this is their value, 14. We would actually call this x equals 14 when we get there. So that's our random variable. That is our sample value, 14. So now we're saying, to determine if these data provide convincing evidence that more than 20% prefer the last kiss they taste, 100 simulated SRSs were selected. Each dot in the graph shows the number of students out of 22 who preferred the last chocolate, assuming each student had a 20% chance of choosing the last kiss. So again, we did simple random samples, simulated. Okay, and somehow they had to have 5 choices. So maybe they, we did the numbers 1 through 5, 1, 2, 3, 4, 5, and we had a random number generator pick. They picked 22. So they listed out 22 numbers, and let's say we counted the number of 5s, right? The number of 5s, and that is what our X value is. That's what all these dots are. This is how many people picked the 5th chocolate as their favorite. And again, we assume that each one had a 20% chance. So there's an equal chance of each one being picked. That's why it's a simple random sample, equal chance. So part A, explain how the graph illustrates the concept of sampling variability. So this is just a very plain Jane answer. So it says, if researchers repeatedly take random samples of size 22, from a population of students who show no preference, for what they taste last. So this is showing us what we did, right? Assuming each student had a 20% chance of choosing the last kiss, assuming that there's no preference. the number of students in a sample who prefer the last kiss varies from, and now we just look at our numbers from 1 to 10. So that's a lot to write down for that little bit, okay? But again, that first part is very important. Repeatedly take random samples of size 22. It's from a population where there's no preference. Your number of students in a sample would vary from 1 to 10, picking the last chocolate. Okay, I got one more question based off this. Okay, so B. Based on the results of the simulation, is there convincing evidence that people have a preference for the last kiss they taste? Explain. So again, our sample value was 14. If people have a preference, we're looking for how many times 14 or more would appear in these simulations, because 14 would, 14 would show that this value could happen. More would even be more of a majority picking the last kiss. But again, this simulation is saying, how often does it happen by chance? When you do a simulation, you're looking for the by chance happening, probability, by chance, just getting lucky, by chance, okay? So let's look. How many times does 14 or more occur? Well, look. 10 is your last one. There is no 14s or higher. So that means that in these 100 simulations, you got 14 or more 0 times out of 100. That is 0% of the time. So the by chance probability of getting 14 or more out of 22 picking the last kiss never happens. So it just doesn't happen by chance. It just doesn't happen by chance. So the fact that it did happen, the fact that 14 of the 22 did pick the final kiss, means that these people really do like the last thing they taste. There is convincing evidence. There is convincing evidence. There is convincing evidence. So again, remember, when we talk about convincing evidence, we're looking to compare it to 5%. 0% is less than 5%. If something happens less than 5% of the time by chance, then we think it means something. That provides us with convincing evidence of what they're trying to show. But if something happens more than 5% of the time by chance, then we say, that could just happen. Sampling variability. It just is what it is. I'm not going to read too much into it. Okay, so again, I talk about this the entire year. This is really the second time we did it in the POP, You're a Winner activity. But again, this is a common theme that you need to get straight. And a lot of people think higher percentage means convincing. That's not. It's backwards thinking. Lower percentage, rarity, gives us convincing evidence. So we're going to say something like this. In 100 simulations, a result of 14 or more students preferring the last chocolate and you could say occurred 0 times, or I'll be clever and say never occurred. And in parentheses, I put 0 out of 100, which is 0%. So that is me explaining in the simulation how many times our result occurred. And again, notice the 14 or more. A lot of people forget the or more or less, depending on what you're trying to measure. This was 14 or more. Therefore, oh my goodness, I'm going to run out of room. I'm going to put it right up here. So I'm going to continue. No, I'm going to just keep going. Therefore, there is convincing evidence that people have a preference for the last kiss they taste. For the last kiss they taste. Oh my goodness, I didn't know I could write this slow. And again, in parentheses, you're going to put 0% is less than 5% because that's what we compare it to. So hopefully you can read all that. It says in 100 simulations, a result of 14 or more students preferring the last chocolate never occurred. And again, that's what it shows on the dot plot. Therefore, there is convincing evidence that people have a preference for the last kiss they taste. 0% is less than 5%. So again, if you had to turn your volume down, it's because I think this stuff is important. And I'm looking forward into this class and saying what is going to carry over. This is something that is going to carry over. So please, please, please try to wrap your head around. We're looking for rarity. Rarity provides convincing evidence that the actual event matters. Keep that in mind. All right. Sorry, this is a little bit long. Good luck on your homework.